What's up everyone, Patrick here, welcome back. And in this next example, we got to determine the shortest distance from the line y equals 1 over 3x minus 2 to the origin. So the origin, as we know, it's at 0 and 0. So what I'm going to do for this question is follow the exact same steps that we went through in the overview video in the first example that we did. So when I'm doing this, I'm assuming that you watch that video because I go through the general steps in more detail in that video. So I'm not going to write out the steps again. I'm just going to follow them in this example. And then also in that overview video at the end, I showed you a formula for these kinds of questions for the shortest distance between a line and a point that you can use. And I'm going to use the formula at the end too, to make sure that we're getting the same solution as when we follow the steps doing it the long way. Now in your class you may use the formula, you may not, but I'm going to go through it just in case you're interested anyway at the end. So we got y equals 1 over 3x minus 2. So how does this line look like? Well, the b value is -2, so the y-intercept is -2 over here. And then notice 1 over 3, it's a positive slope, so it's going to be a line like this, roughly. Not to scale, but just the rough shape, that's how it's going to be. Now, the origin, it's at 0 and 0, which is over here. So what we got to do is find the shortest distance from the origin to this line over here. And remember, the shortest distance is going to be the perpendicular distance, meaning that this line over here, the distance line, has to be perpendicular to the line that you're working with. So as a quick review, what we got to do is we got to find the equation of this line. This line we already have the equation over here, but we got to find the equation of this line. Then we got to find the point of intersection between the two lines, which is going to be here. And then we take the origin, we take that point of intersection and find the distance between them, or the length of this line segment. That's going to be the shortest distance. So first step is we got to find the equation of this line. So notice that the slope over here of the first line, it's 1 over 3, right? Because it's in y equals mx plus b form. So the slope is 1 over 3 of the original line. So if the slope of this line is 1 over 3, what's the slope of this line going to be? Well, it's going to be the negative reciprocal of this because those lines are perpendicular. So we would flip this over here, which would be 3 over 1, and then we change the sign. Notice this is a positive, so this is going to be a negative now. And so -3 over 1, that just ends up being -3. So we have the slope of this line, and we also have a point on the line, which is 0 and 0. So now we find an equation for that second line with a slope of -3 and a point 0 and 0. And notice 0 and 0, it means the y-intercept is 0, which means the b value is 0, so it just means the line is y equals -3x. But if you wanted to do all the algebra, you would do y equals -3x plus b, plug in 0 for y, plug in 0 for x, and you'd end up with b equaling 0. So there's like a -3x plus 0 over here, right? Which would just be -3x. So this line over here has an equation y equals -3x. So we have that line, we have the original line, and what we do now is we find the point of intersection between them. So we got y equals -3x. Let me write out these lines here. And we just find the point of intersection between these two using substitution or elimination. What I'm going to do is I'm going to take this -3x, plug it in for this y, so we'd end up with -3x equals 1 over 3x minus 2. I'm going to bring the -2 over, I'll bring this over, like that. So we got 1 over 3 plus 3, which is like over 1. Lowest common denominator between 1 and 3 is 3. So we'd end up with 1 over 3 plus 9 over 3, which would give us 10 over 3. So this here, this right side ends up being 10 over 3x. This ends up being 2. So over here we'd have what? Divide both sides by 10 over 3 to get the x by itself. So we'd have 2 over 1 divided by 10 over 3, which would be like 2 over 1 times 3 over 10, which would give us 6 over 10, which would give us 3 over 5. Okay, so these cancel out. The x ends up being 3 over 5. So this point here, right, that's what we're finding right now. It has an x value of 3 over 5. And I'm going to keep everything in fractions just in case your final answer has to be as an exact value. If you don't have to do that, then from here you could work with decimals. If you feel more comfortable, it's tougher to work with fractions, so I'm going to stick with the fractions. So we got 3 over 5 for the y value, or the x value rather. Now to get the y value, we could take this 3 over 5, plug it in here for this x, or this x will get the same y value. I'm going to plug it in for this one, so we'd have y equals negative 3 times 3 over 5, which would give us negative 9 over 5. So the y value would end up equaling negative 9 over 5, like that. So now what we do, we have that point of intersection. What's the last step? Well, we got to find the distance between those 2 points. And to find the distance, we would use the length formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to label these points here. So I'm going to let 0, 0 be x1, y1. I'm going to let this be x2, y2. So we'd end up with x2, which is 3 over 5, minus x1, which is 0. That's going to be squared. y2, which is negative 9 over 5, minus 0. That's going to be squared. So over here, we'd have the square root of 3 over 5 to the power 2 plus negative 9 over 5 to the power 2. Remember, when we have a fraction to an exponent, we could take the numerator to that exponent. We could take the denominator to that exponent. So this would end up equaling 9 over 25. So we'd have the square root of 9 over 25. Over here, applying the same thing, negative 9 to the power 2 over 5 to the power 2, which would give us negative 9 to the power 2 is 81. And then 5 to the power 2 gives us 25, like that. And so from here, what's nice about this is it's already the same denominator, so we could just add the numerators. So we'd have the square root of 90 over 25, like that. Now from here, notice that fraction 90 over 25, we could simplify. We can divide the numerator and denominator by 5. So 90 divided by 5 would give us 18. 25 divided by 5 would give us 5. So the square root of 18 over 5 is the answer. That's the shortest distance as an exact value. Now you can also get the decimal for this if you want, and then it's much easier. You don't have to do a lot of the work. You can just plug stuff into your calculator. So the final solution may be in decimal values, but it may also be in this kind of format. Okay, so I just wanted to leave this here. And there's actually other formats this can be in. So at this point, depending on your teacher, they may be okay with this, but this can actually simplify a little bit further, the square root of 18. So I'm going to quickly just show you how it could simplify further, just in case your teacher, your specific teacher, expects you to go a little bit further, or the textbook solutions show a different format. Because a lot of times you'll get an answer like this, and then the textbook will have a completely different looking solution. But if you actually plug them in, both in, you'll get the same decimal value. Okay, and this is an example of where you can get a totally different kind of solution at the back of the textbook, even though yours looks different, but it's the exact same thing. So the way this could simplify further, if you have a fraction, remember the square root of a fraction, you could take the square root of the numerator over the square root of the denominator. So I got the square root of 18 over the square root of 5. Now, one thing I want to mention at this point, don't get too intimidated with what I'm doing here. If your teacher is okay with just this solution, then don't even worry about this here. You can watch it just in case you want to learn how to simplify this kind of stuff. I think it is useful because eventually in higher grades you are going to have to know how to simplify this. But I'm going through this just in case your specific teacher is a little bit more picky. So square root of 18 over square root of 5, that's the same as this. Now, this square root of 18, that can simplify because we can break this down into root 9 times root 2. We could break it down into a factor where the square root of it is going to be smooth. Notice that the square root of 9 is going to be 3. And then this is going to be all over root 5. Okay, so the square root of 9 times the square root of 2 is the exact same thing as the square root of 18. Just in general, if you got two things multiplying like that, you could break it down into that. So what we did was we took the root 18, broke it down into root 9 times root 2 in this format, the a times the b, and then we got root 9 times root 2. And then root 9 ends up equaling 3. So we end up with 3 root 2 over root 5. So this and this, they're the exact same thing. Okay, if you plug this into your calculator, you plug this into your calculator, the decimals will be exactly the same. And look how much different this looks from that. Right? So that's what I'm talking about in being in different formats, textbook solutions being in different formats. In fact, this can be in an even more different format because a lot of times teachers and textbooks, they don't like having a square root in the denominator. And so what they'll do is they'll do something called rationalizing the denominator, where you get rid of a square root. I have a bunch of videos on this. It's in higher grades, but if your teacher is going through rationalizing denominators or you want to learn about it, just let me know. Send me an email and I'll send you a link to those videos. But the way you get rid of a square root is you take the expression and multiply it by that square root value over the square root value. So it's like we're taking the expression, multiplying it by 1. So anything we multiply by 1, we're keeping the same. Okay, so we're keeping it the same, we're just changing the format. So what would happen here is you'd have 3 root 2 times root 5, right, if we combine the numerators. And then notice what's root 5 times root 5? That's just 5. And so that's how that square root goes away. And then from here, notice root 2 times root 5, that simplifies into root 10. So 3 root 10 over 5 is another format. Okay, so this, and this, they're all the exact same thing, right? And look how different they all look. But if you plug them all into your calculator, they'll all give you the same decimals. So that's why I wanted to go through that just in case these solutions are going to be in different formats, right? So that's how you do it the long way. Now, to do it the short way, if you remember, we can use that formula that we went over in the overview video. And just as a quick review, let's say that we have a line. Remember, the line has to be in standard form, so we're actually going to have to convert this line into standard form. Okay, if we have a line and then we have a point right? In this case, the point is 0 and 0. But just in general, the distance between this point and this line, it's going to equal the shortest distance. It's going to equal the absolute value of AM plus BN plus C all over the square root of A squared plus B squared. Right, the formula that we went over in that video. If you didn't watch that video again, highly recommend you do, because I go into more detail about this line, what this absolute value means, etc., etc. Right, but that is the formula right there. So what we got to do is take this and convert it to standard form. Now, what we first want to do, so even though this is a short form way, there's still a little bit of work sometimes, especially if you're dealing with fractions. So to convert it to standard form, remember we got to get rid of this fraction. So we have a denominator of 1, 3 and 1. Lowest common denominator between all those is 3. So we'd multiply this by 3, multiply this by 3, multiply this by 3. So we'd have 3y equals 3 times 1 over 3, which is x, right? Because 3 times 1 over 3 is 1, so it's like 1x. And then minus 2 times 3, which is 6. Then let's bring the 3y over. X minus 3y minus 6. So that's the standard form line. It's in this format over here. So notice from that, the A value is 1, the B value is -3, and the C value is -6. All right, and then the M and the N, that's the point that we're looking at, the distance from the line to that point. In this case, it's the origin, so it's 0 and 0. So in this case, the M is 0, the N is 0. And so we just have to take those parameters, plug them in here. So we'd have A, which is 1, times 0, the M value, plus the B value, which is -3 times 0, minus 6, all over the square root of A, which is 1 squared, plus the B value, -3 squared, like that. Okay, so what happens here is we just got to simplify this. This is 0. This is 0. So we just end up with the absolute value of -6 over the square root of 1 squared is 1, -3 squared is 9. So what happens here, the absolute value of -6 is +6. Remember, the absolute value takes any negative, turns it into a positive. Any positive keeps it as a positive. And then 1 plus 9 is 10, so we'd have a root 10. So we end up with 6 over root 10. But notice if we take this compared to these, it's not the same, right? But it actually is the same. So this is another format that the answer can be in. If you plug this into your calculator and plug these into your calculator, it'll be the exact same decimal, right? So a lot of different formats this can be in. Now, how can we show that this is equal to one of these? Well, the quickest way to show that two exact values are equal is to rationalize the denominators of both, because then it has to simplify to this over here, where there's going to be a number left in the denominator. So to rationalize this, remember, we multiply by that square root over that square root, right? The square root that we're getting rid of. So we're taking this, multiplying it by 1. So we'd end up with 6 root 10, right? 6 times root 10 is 6 root 10. And then root 10 times root 10 is just 10. And then notice the 6 over 10 simplify to 3 over 5. So we'd end up with 3 root 10 over 5. And notice that's that right there. Okay, so again, you might not be expected to know how to work with these exact values in your particular grade or in your particular class, but you may be expected to. So again, it's just why I wanted to go over it. All right, but the most important part, where you're going to get most of your marks, is showing those steps that I went through before. A lot of times your teacher's not even going to go over this formula. Again, I just want to show you it in case you want something to check your answers with. But the most important thing is going through those steps of where we're finding the equation of that perpendicular line, finding the point of intersection, then finding the distance.